Hey guys, welcome to another tutorial, and today we are going to be talking about a third solar upgrade we've done. As we see in front of us, we've got some blinking lights. So yeah, we're going to be talking about the solar setup and how I've rigged it up now. I've just done this stuff today and not so long ago and just finished the setup, and now I'm going to be showing you. So this is take 4 of off-grid take 4, and this is solar upgrade number 2. So without further ado, let's get into it. So the first major upgrade we done today is I went to Super Cheap Auto yesterday with a bro, which shout out to Hori, and brought a MPPT Ridge Rider charge controller. So this is a 10 amp 12 volt 24 volt MPPT charge controller. So I had a PWM charge controller on this previously, but this is now upgraded to an MPPT charge controller. But I am also going to talk about the PWM controller too, and the reason why is because we are also using the PWM controller as well as this new MPPT controller, and we also added another battery to the system. So yeah, let me explain how it works. So you've got 3 pairs of wires. So you've got your panel wires. This is the one closest to the lights. You've got your battery wires, and then you've got your load on wire. So this is the wires where you can stick a load directly on the charge controller itself. The PWM has one of those too, where you got the 2 wires, but also the PWM has the USBs, which this MPPT charge controller does not. But that's okay, because the MPPT charge controller will charge the main battery fast. So the main battery, which my inverter's hooked up to, and also I have a LiDAR socket hooked directly to the battery. If we have a look here, we've got a LiDAR socket. Excuse the mess on the table. Just been doing a lot of projects, but I'll show you. So here, and I bought this for 20 bucks off the bro, Hori. This is just a LiDAR socket, another one, because I have a LiDAR socket for my shower as well that is still hooked up to the PWM controller. This is just a one for a fridge that I've got, which I brought off the bro. I paid for the rest of it this week. So this is what my off-grid fridge is going to go on. It's a 3-in-1. I'll do a review on it another day, but that is what that is, and that's just hooked up to the main deep cycle battery. So, and this is what the battery leads are on this charge controller is connected to. So you've got the panel, you've got your battery, and then your load on. So the load on, and the reason why I said I'm going to talk about the old PWM one is because we're still using the PWM at the same time. So the load on, this one actually goes into the input of the PWM. So if I show you the PWM chip, which I'll take this as well because this is the electric eye we're going to be using to see. But if we look, so here's the wire. This wire here, this is the wire that I cut. I've cut another extension cable and goes into the PWM chip that sits over there. So here's the new battery. So this battery is on the system as well, but the only time this battery will get used if anything on the PWM controller gets plugged in, or if I hook something directly to this battery. So the downfall of this at the moment, until I get the device that reads the voltage on the main battery, this will only read the voltage on the small battery that's connected. So at the moment, if we have a look at what we got here, so we've got the load on 12.1, so it's at 12.1. so this battery is really dead, but this should be charged by tonight. And the thing is, this PWM controller will still run at night time. And the reason why this will run at night time is because technically this is on the load on side of the MPPT charge controller. So you go from the load on to the MPPT charge controller to the input side of the WPM controller. Then you've got your battery wires. You've got your battery wires as well, and then you've got your load on that comes out of the PWM controller, which is powering my shower. And also the USBs on here. This is the top one is the lights for the front light on the outside, and the bottom one is my inside lights. So yeah, so now I can run my inverter for longer. So I haven't really tested this out in depth for how long it takes to charge, because I just set this up today. So I'll be going through a few experiments, and if you watch my first solar tutorial, I actually showed the panel that's on the roof. So the solar panel is still in the same spot, and everything else is still in the same spot except for the new MPPT charge controller, which is here, and the 12 volt little battery that I've got here, which the good thing about this too is I can also use this as a battery charger. So I could plug batteries to this, any type of batteries, and it'll just charge it. Car batteries, truck batteries, as long as they're 12 volt, I'd be able to charge it on this side. So yeah, and the good thing about this, see, at the moment the main battery is charged, that's why this light here is blinking, but the panel is still on. So what's happened now is, since this charge controller is in float mode, whatever power doesn't get used to go to the battery, it's going to give the load on more power. So say for example, if I use my inverter at night time, flatten the battery a bit, and if this was to charge the battery back up, this will take first priority, the battery, and would sacrifice a little bit of load just to go to the PWM. But then when this is charged like this, seeing it's fully charged, and then the panel's still going, it's still on, that means that the panel is getting used and the battery is just floating. So the panel is getting used, and and it's still getting used by the other controller. But as I said, at night time, this load on connection still stays live, so that means the PWM controller will work regardless of day and night. The only time it won't work is if the battery is flat and there's no solar being produced by the panel. So that's the only time it'll stop charging the PWM. So I just thought I'd do a quick tutorial on the new upgrades. Hopefully you learned something new, and everyone have a good day, and until next time, cheer.